All right, so these are super important. 1 square root of 2. But what if I didn't have it as the square root of 2? What if I had it as a 5 here, but you knew it was in a 45, 45, 90 triangle? Then you should know the other sides. What would they be then? 5 over root 2. 5 over root 2. And do you get how the ratios have stayed the same? If I wanted that square root of 2 thing to come back, I would just times everything by square root of 2. And then these would cancel. These would cancel, and it'd be 5, 5, and 5 root 2. And that looks more like what we're used to. Okay? So along those same lines, I'd like you to look at, wait a minute, there, this one, and tell me if I make this side right here a 7, what would the other sides be? 14 for this one, because that's double that one, and then 7 root 3. All right. What if the side that has the root, that's the trickiest one, what if I made that 11? 11 over root 3 and 22 over root 3. Just double that other one. All right, good enough. How about these guys? 30 degrees is pi over 6. Would you please see if you can complete this dealy bob? You should know what 30, 45, 60, 90, 180, and 360 are all in pies. Just make sure you're solid on all of those. If you could only be given one of these on the test, from which all the others could be derived, which one would you pick? 180. It's equal to what? Pi. So then you know 2 of them would be 360, 2 pi. And then half of it would be pi over 2. And 60 would be pi over 3. And this would be pi over 4. And then again, the original's right there. Any questions on those? So when they ask you for what sine of pi over 4, it should be, it's sometimes easier for me anyway, to change it to sine of 45. Because then I go, oh yeah, the 45, that's a 45, 45, 90. I know that one. All right. So if I say cosine of pi over 6 right now, in my mind it goes, oh, cosine of 30. And then I know what triangle that makes that, right? Super easy, don't even want to bore you with that one. How about this one? Cosecant of pi over 3. Well, that one's really cosecant of what degree? 60. And I really don't want to do cosecant. What do I want to do? Sine. And then I got to take my answer, though, and do what to it? Go ahead and do this one. Draw yourself a triangle and figure out cosecant of pi over 3. So if you know it's a 60, you know you can draw a triangle, and you can put a 60 in the triangle. Now, how you draw it is up to you, but you always have to label it with the 1, the 2, and the square root of 3. And then you ask yourself, cosecant of this would be the flip of sine of 60. Sine of 60 would have been root 3 opposite over hypotenuse 2. And then I got to flip that, so it's 2 over root 3. Final answer. Raise your hand if you had that one the same as me. All right, good. If you didn't, do you have any questions about it? Again, I did sine of it was opposite over hypotenuse, and then I flipped it. All right, this is the hardest one because kids really mess up on negatives on this next test you're about to take a lot. So let's practice one that's got a negative in it. Sine of negative pi over 4. That's the same as sine of negative what degree? 45. Where the heck is negative 45 degrees? It's down there. Draw yourself this triangle and then tell me the answer. Don't say it. Figure it out. So Mr. G, what would I say for these sides? Yes, I could say Mr. S, but anyway, go on. You're saying that that's negative 2. Is that what you're thinking? I'm not saying you're wrong. I'm just asking. Okay. All right, so what if, I kind of drew that funny, and pi over 4 is 45 degrees, right? So that's probably more like what 45 degrees looks like, and that might help you. If these two are the same as each other, do you know what numbers I should be using for those? So if I use 1 and 1, now there's something slightly wrong. Yes, there's a root 2 here, but there's got to be a negative right there. Because of where I am. I'm down here in this quadrant. All right, so now sine is opposite over hypotenuse. We always use the central angle. Opposite is -1. Hypotenuse is root 2. -1 over root 2. And you see how easy it would have been to forget that negative? And yet it's a totally different answer because the triangle's in a totally different place. The whole triangle would have been, I had to reconstruct right in there to make it positive. All right, moving on. Inverses, that's the new thing we've been doing. So if we have inverse cosine of 2/4, would you agree that 2/4 is pretty much the same thing as a half? So in this kind of a problem, they're just asking me for the angle or the degrees, and whenever it's an inverse, they have given me the sides, and they're asking you for an angle. So how many degrees is it? Well, I know I'm in a triangle that has a 1 and 2 as sides, and it's probably one of the it's got to be the 1, 2 square root of 3 deal. 1, 2 square root of 3 deal. And then this angle right here, cosine of what angle would give me 1/2? Cosine is adjacent over hypotenuse. That wouldn't even work. It'd have to be this angle here, right? Would give me a cosine, would give me sides of 1/2. So which angle is that? That's the 60. Because the 30 degrees has to be down in there. All right? So that one's 60. Now some people like to do this a little different way. Let me show you. Some people like to rewrite it and say, instead of inverse cosine, I want to rewrite this thing as, here, watch. If I take the cosine of both sides, and you say, what other side is there? There is no other side. I'm going to make a theta there. Now if I take cosine of both sides, do you see how the cosine will cancel the inverse cosine? They'll be just gone. And now I've got cosine of theta is 2/4. Cosine of theta is 1/2. 1/2 is the same as 2/4. Now it's set up more like you're used to, where the angle is where it's supposed to be. So you can ask yourself what angle would have to go there, and it's 60. Probably need to draw a triangle to figure out. All right, you learned this arctan. You learned that that's the same as inverse tangent. I hope you learned that yesterday. So it's the same as this. Now remember, on this kind of a problem, they want you to tell them the degrees. So this is not the degrees. That must be the sides. Can you have a triangle that has a side of 0? No, so this cannot be a normal triangle, and therefore, when you're drawing it, don't draw a triangle. You can't draw a triangle with a side of 0. But you can go to one of these spots. The answer is either here, or here, or here, or here. And you should have those spots memorized. Would you please, right now, on your paper, refresh your memory of what this is. What, comma, what? What's this? What, comma, what? What's that? What, comma, what? And what's that? What, comma, what? And then figure out where tangent sides ratios would have an answer of 0. And then you'll know how many degrees it is. Is it at 0, 90, 180, or 270? That's a very good question. Can there be two answers? If there are two answers that work, then yes, you should give them both. So what I wanted you to do right there was to write this down: 1, 0, 0, 1, -1, 0, and 0, -1. Which of those have the tangent, which is the y over the x, equal to 0? These two. So therefore 0 and 180 are your answers. Raise your hand, sir. If you knew that, you would have probably got that right on the test. Okay, good. Any questions about that? Yes?
Oh, sorry about that.
It's all right.
When you're measuring an angle,
Yep.
just like relatively go to the hypotenuse.
If you're measuring the angle, you always start there, And then where the other side is, I'll draw that with a straight line right here. I'll use one of those. Now that one, it's pretty obvious. It's a small angle, and everybody knows how to do that kind. But if I move it around, I always go to, I keep that green as the one side of my angle. Now I'm at like a 45. Now I'm at like a 90, 150 or so, 180. So you always measure from there all the way around to wherever you stop. Does that make sense?
Yeah.
All right. Okay. Solving equations. You got to get the variable alone. One of these equations does not have a variable. Which one is it? First, second, or third, or fourth one? Probably depends on how you number them, but yeah, this one. If I say equals theta, it's kind of cheating, but I'm adding in my variable, aren't I? So do you get the point that on that one you really don't have to solve for theta? It's already alone. Theta's already there. But what do I have to do to get that one alone? I just need to simplify it. Do you remember how to simplify something like that? Yes, it's true you start on the inside, but there's a fast shortcut on this. Yeah, because inverse sine and sine will cancel. Whoop. Answers I have. Now, could you have done it the long way and started on the inside, figured out the answer, and then do the outside? Yeah, it'd still come out to half. All right. How about that one? X equals 8. How about this one? How do I get the theta alone? I got to get rid of sine. How can I get sine to get off of there? Inverse sine, that's what it's good for. Do it to both sides, but I really should move this over. And now I do inverse sine to that side. There. Cancels. Theta equals inverse sine of 4/5. And if you had a calculator, you could just type it in and be done. If you didn't, this one you couldn't do because those sides are not the side lengths that you know. It's not either 3069, it's not a 30, it's not a 60, it's not a 45, it's not a 90, it's not a 180, it's not a 270, it's not a 360. You could do all of those from drawing the little picture. Either a triangle or one of these like, I forgot what they're called. Quadrantals. Okay. I would like you to look at this one with me for a moment and see what do you think we should do first. We're trying to get the theta alone. Divide by 2 is correct. If we divide by 2 here and here, that'll cancel that. And now what's 8 pi over 2? 4 pi. So sine, inverse sine of theta is equal to 4 pi. Do you see how they did not tell me the sides here? And they did tell me the angle? All right. So what they're asking is, what would the sides be like if we were at 4 pi? This is kind of a weird question. You're right, it's 360, same as 2 pi, right? So we're over here. And what would the spot be right there? 1, 0. And which one is sine? So I'm thinking that one's 0. I'm also thinking you're not going to see one like that on the test, so it's a little weird. All right, moving on. Definitely see something like that and it'd be an R2. Try it. Always ask yourself, did they give me sides or did they give me an angle? And if they gave you sides, then they want an angle. If they gave you an angle, they want sides. Now, the way I'd probably do this, I kind of like it when they're written the other way. I might take sine of both sides, and then I'd say sine of theta is equal to root 3 over 2. Because you've seen problems written that way for a long time. And then I'd say, okay, it's root 3 and the 2. I know which kind of triangle we're talking about. It's a 1, 2 square root of 3 triangle. So I'd go, okay, sine of this angle is opposite over hypotenuse. And then it's got to be 1, 2 in the square root of 3. The side must be 1. I drew the triangle really funny, but I've labeled it right. So what kind of angle was I at? 60. Because I know the way I drew it was kind of wacky. I'm going to redraw it just because I know it's going to bother some of you. And this was 2 opposite of sine is opposite. Oops, sorry. Root 3 over hypotenuse, and that one's 1. There we go. And now you can tell I'm not at the 30-degree angle. I'm at the 60. Questions? Okay, let's move on. Try that one. It's some more inverse trig. Should be right in your wheelhouse. Should be doable. So my first thought would be, I really would rather see this as a regular cosecant. So it's cosecant of theta is equal to 2. And I usually put that over 1. And then, instead of using cosecant, I probably would rather use sine, because I've got buttons for that, and it just, I'm more used to that. It's the same thing. It's okay to do that. And then I just got to ask myself, sine of what is a half? I know that one. That's 30 degrees. If I didn't know that one, I'd draw myself a picture. I'd say opposites 1, hypotenuse is 2. It's got to be this one. And this must be how many degrees then? 30. Raise your hand if you had 30 degrees. Good. Okay. Now, if we're going to go from inside out, this is the more like our 3-ish level stuff. Start on the inside. Figure out what that answer is. And then take the arc sine of that. Remember, arc sine just means sine to the negative 1. Inverse sine. Same thing. But start in here. Do you know what pi over 3 is? Pi over 3 is 60. So it's really cosine of 60. Now to figure out cosine of 60, I'm going to make myself a little triangle with the 36. Oh, that's a terrible triangle. 30, 60, 90, and this would be 1, 2, square root of 3, and from cosine's perspective, cosine of 60, that one right there, cosine is adjacent over hypotenuse, which would be 1 over 2. You get that? And now I got to do the inverse sine of that. Whenever you're doing inverse sine, it's given me the sides, so I'm supposed to tell it the angle. Sine of what is a half? 30. Got that one memorized. Otherwise, I could go back to this and say sine of which of these two angles, the 30 or the 60, would be a half. And it would be this one right here. So it's 30. It's final answer. Just 30. Because it's not negative, it's just 30. If it had been negative, then it could be like 150 or something like that. Oh, I see what you're saying. Oh, you got me there. Okay, hold on. So what you said is, how about instead of 30, could we say 150? Then if I make my triangle and draw it with a 30 here, then this is 150, then this would be 1, this would be 2, this would be square root of 3, and they're all, no, that one's negative. Okay, and now I do sine of that, opposite over hypotenuse. I don't see any reason why that couldn't be right. I think you're right. I think I should have been saying 30 and 150.
So we would have to, it would be wrong if it was
Yeah, you would have been. Glad you caught me. Thank you. All right. Let's try this one. Start in there. Hopefully you can just do what angle would work so that tangent would be 1. Do you remember that one? In your head? Okay, if not, then you better go make the triangle so you have the sides that are 1 and 1. How many degrees must that be? 45. If that's 45, what's cosine of 45 then? Well, I go back to this triangle and say, what's cosine of 45 degrees? Cosine of that, adjacent over hypotenuse, I need the hypotenuse now, and that's 1 over square root of 2. Now, could that have two answers? No. It's when they're asking for the number of degrees that you might have two different answers. They'll give you the right answer. This one was asking for, at the end, what I was figuring out was what the sides were. Yes?
It's not really a second answer, but I put root 2 over 2.
Ah, yes. 1 over root 2 is, yes, you could do this and make it into root 2 over 2. You're absolutely right. Yes?
Someone asked if it doesn't ask for like all answers, just for one, would we say the one for that 30?
I'm going to say that anytime you're supposed to get, anytime you have an inverse sign is the last thing you do. Like if you start in the middle, you might be doing something different. But when the last thing you're figuring out is an inverse, then you should be looking for maybe there's a chance of two answers. Not always, but sometimes there will be two answers. So if you want to give them an answer in degrees, watch out that there might be more than one. And it'll always be better to give me both answers than to hope that I only wanted one. But don't worry about it when you have sides. When you're supposed to give an answer like this, then just give one. You don't have to look for a second one. But when you're looking for answers that are like degrees, maybe look for if there's more than one. Okay, so what are inverses again? They're things where the domain and range gets flipped. Do you remember when you did inverses? You'd have the x's and the y's, and then you'd replace them. You'd like replace all the x's with y's and all the y's with x's. That's what's happening when you have an inverse. So let me show you what that looks like when you have the graph. Trig functions will pass the vertical line test. In fact, any function will pass the vertical line test. But to do an inverse of a trig function, it needs to pass the horizontal line test. Let me show you what I'm talking about. So here's sine. Do you agree that sine passes the vertical line test? A vertical line looks like this, right? And we see it, does it ever touch twice as I'm, what? I hate that. See if it ever touches twice as I move like this, and it never does. So it passes the vertical line test. Would it pass the horizontal line test? No, and therefore it does not have a inverse that is a function. But if I only narrow this down to part of sine, remember how sine keeps going like this? If I narrow this down to only part of sine, then I can make it have an inverse. Otherwise, inverse sine isn't even a function. Inverse sine is only a function between there and there. Do you get that between those two green lines it would pass the horizontal line test? All right, so that little zone becomes really important. Would you please graph this of sine in your notes? Because this is the part of sine, the only part of sine that has an inverse. And therefore, it's the part that can tell us the domain and range of inverse sine. And you are going to be tested on that. About a week. All right. So, So if this is from pi over 2 to negative pi over 2, that's sine's domain. So it's inverse sine's what? Range. So if I were to say inverse sine, the domain and the range of inverse sine, I can look at the domain and range of regular sine and then flip flop them. Let me show you what I mean. So do you get how this sine only goes up to 1 and down to negative 1? Do you get that? That's called its range. The range of sine is from negative 1 to 1. Does that make sense? So then what's the domain of inverse sine? Negative 1 to 1. And the range of inverse sine comes from the domain of sine. Negative pi over 2, pi over 2. Remember, we only picked part of sine. Only this little part of the graph of sine. If we continued it on, you know, it would have been going like this and stuff. But we can't do that part because it's not, that part won't give you a function. So we have to limit the domain and range of sine so that we can have an inverse. Yes? Good question. Can you actually get to the ends of them is really what he's asking. All right. How about this? At the asymptote lines, would you agree that those have to be parentheses? I agree. And then for the domain, let me think it through. I really didn't think about it when I put them up there. Can it touch negative 1 and 1? Yes, it can, even though it's doing so at an asymptote. That gets weird. I'm going to have to get back to you on that. I'm going to leave them as parentheses now, but they might be brackets. I'll know that for sure by tomorrow. Okay. So if I took sine, remember, it goes like this in the little zone that I'm looking at. That's what sine does. Do you get that if I flip this thing and make it an inverse, that now instead of the domain and range being where they were, now it goes from negative 1 to 1 and pi over 2 to negative pi over 2. Those are in the opposite spots as they were before. And to get an inverse, you flip it over the line y equals x. So I should take that red line out of there after I flipped it. I'm going to flip it first. So I'm going to flip it over that line. And now, that is the graph of inverse sine. We're not going to be asked to graph inverse sine, but there's an official calculator graph of inverse sine. Now, just the main things you'd be expected to know is when I ask you, what are the domain and range of inverse sine? Here's inverse sine. Here's its domain. Domain goes this way. Here's its range, going this way. The way I'd probably try to remember it is I go back to the regular graph of sine, and what was sine's domain and range? Whatever sine's domain and range are, you flip them. So let's go back there a second. Here's sine. Here's its domain. Oh wait, I can't do that part of sine. I can only do this part of sine. What was its domain and range? It's going up to 1 and down to negative 1. And it's going from pi over 2 to negative pi over 2. So its domain was this. So when they ask me what's the range of inverse sine, I'll look for the domain of that. And when they ask me for the range, no, the domain of inverse sine, I'll look for these numbers, whatever the range was. All right. Again, that's what the picture looks like. I tried to show you where it came from. You're not going to be asked to graph it, but you will be asked what are the domain and range of inverse sine. And then again, I'd go back to what's the domain and range of sine. Just flip them. But it's not domain and range of all of sine. We have to only do that one little part of sine. Just this little part that goes like this. because that's the only part that would pass the horizontal line test. All right, let's talk about the same thing for tangent. Do you get that normal tangent goes like this? Would you please label normal tangent, please? Because if you know what normal tangent's domain and range are, then you can find inverse tangent super easy. Just do normal tangent. We'll do this later. What's it go from? From something to something? Corzempa. Give me some numbers. What does it go from?
Pi to pi.
No, that's,
Pi to pi.
you're close. Negative pi over 2 to pi over 2. Because the whole thing is a total of pi. You're right about that. I knew what was going on in your head. But then it only goes halfway in each direction. So, okay. And now how about the other end? It normally goes, well, yes, there's a 1 and a negative 1 here, but is that where it stops? Does tangent stop at 1? No. So its range, the range of tangent, is how low does it go? Negative infinity to positive infinity. This is for normal tangent. And the domain was from negative pi over 2, and I never got there because it was an asymptote line, to pi over 2. So now as soon as you've written out domain and range of tangent, it's really easy to know what the domain and range of inverse tangent is, because you just flip them. So if I asked, what's the domain and range of inverse tangent? You'd say, well, wherever the domain was here, that's now the range of inverse tangent. And wherever the range was, that's the domain. Now what would the graph look like? All right, try to picture for a second that we would take this line, y equals x, and we would flip it across that. See if you can see that this green line I draw is flipped across it. See the green line? That's what inverse tangent looks like. In fact, there it is. Notice that the asymptote lines that were up and down at negative pi over 2 and pi over 2, they're still there, but now those spots move to here and here. So those asymptotes are still there. They just go this way. So that's what inverse tangent looks like. So if you think about it, what's the domain of inverse tangent? Goes forever this way to forever that way. That's what we would have expected, because we could look back at the other one and say, what was the range of this one? See, here's the range of that one. It becomes the domain of this one. And then the range, the lowest it goes is negative pi over 2. To the highest it goes is pi over 2. And that one's an asymptote, so I know it never gets there. All right. Does it have vertical asymptotes? Vertical means up and down asymptotes. No. Does it have horizontals? Yes. And they're at x equals, wait a minute, x equals things go up and down. Y equals pi over 2, and y equals negative pi over 2. All right, you've made it through. You didn't even have to know that last stuff for tonight's homework. But I'm trying to get you so that by the end we're doing lots of review. So now we covered almost everything, not everything, but almost everything you have to know for the test. We're getting close. Now we have a lot of time to review it. So your homework for tonight, make sure you skip numbers 21 and 22. They're really weird, and I'm not sure I know how to do them. And your assignment is 17 through 32, skipping 21 and 22.